Action. Hello, professors. This is group 23, and today we are gonna to talk about our lab 3 in distributed computing. My name is Lin Qingmin. Another group member name is Zhu Wang and Qin Zhezhen. And first, because of the time limit, we should run the batch ARIMA first because it's very cost time. And this picture result is from the stepwise method of ARIMA, and we choose the we first divided the data into train and the test set, and this result is 80% of data as training data sets. And we also tried 70% of data sets, but it will cost about 1 hour. And about the function, we first used the automation selection of ARIMA, and the best result is 212. That means the auto regression part is 2, the integrated is 1, and the moving average step is about 2. And then we create a list to store the focus, the forecast value, and I use a start time to record what time begin, and we also add the end time to test that. That needs 2,000 about 3,000 seconds, and this step wipe is used for loop, and each loop we use same values 212, and then we fit this model and we focus it in the one step. As you can see, we use the 0 because the return value is an arrow. So get the first item of array, that is the first value. Is focus, and we append it in the list and append it in the history, and also the new model will be created by the history. That means that we after a step the model will update. Yes, and we created one first. It's batch map, and let me introduce first. And that I import the warning libraries that can remove some future warning that look the consular, make it more beautiful. And first we read this data, and then we set date as our index, and then we choose the carbon dioxide as our target columns, and then we separate it. So this is a batch ARIMA. It's very faster than stepwise ARIMA. So I separate it as 70% of train and 30% as test set. And then we also use the automation selection of ARIMA. And you can see the best model is 212. And I print it to summarize it. You can see all the information about it. And after that, we define the batch update function at 10, which means every 10 step we update the model. As you can see, the for loop is same with the stepwise, but this is more smarter than the stepwise we create the end as the end of focused, and the batch as the test value, the part of test value from start to end. Yes, and we also save the focus value in the focus values, this list. And we also add this data to historic, and after 10 step, we update the model. And we also record the end time, and we print it out. The total time taken to batch 10 ARIMA is what time, and we save the focus and the true value in the local files, and we print we paint the figure like this. And that's what I'm saying. And then I will welcome my teammate to introduce about visualization and add full tests to show why the carbon dioxide can be forecast as use ARIMA to forecast the carbon dioxide. Yes. And first is about visualization. We just wait the result of batch ARIMA. It takes about 6 minutes. So my teammates will introduce this code, and after the result of batch ARIMA, and we would like to run this visualization and add full tests. Okay, welcome, Qin Zhezhen.
Hello, teacher. My name is Qin Zhezhen. And we can take a look at the visualization program. This code generates scatter plots, matrix, and heat map. So the data consists of multiple environmental variables, including temperature, humidity, light, and carbon dioxide. Concentration. Collect periodically from seasonals. Scatter plots, matrix, revealed a noticeable negative correlation, minor 0.47 between temperature and humidity. A strong positive correlation between temperature and light, 0.71. We hypothesized that the reason for this is that brightness is related to temperature, and in general, under natural conditions, the brighter the area of sunlight, the higher the temperature. And a weak correlations between carbon dioxide concentration, that's the other variables or variables. The correlation matrix further confirmed these relationships, highlighting the potential collinearity between temperature and light, while carbon dioxide appeared relatively independent with a maximum correlation of 0.20. Some outliers were observed, particularly in the light and the carbon dioxide variables, which could impact the analysis and may require further cleaning. Overall, all the data exploration process provided essential insights into variable relationships, helping to identify patterns and dependencies that will inform the stationarity tests and for forecasting models in the next stages of analysis. That's all.
Okay, and the result of batch ARIMA is shown. That takes our 300 for about 400 seconds, and MSE is about 3000. The MAE is 23.36. And look at the visualization, the result of visualization. And yes, that's the data head of the data site, and this statistic information that the Qinzhezhen has been told. And this is the matrix seed map, and this is the scatter plot matrix. And welcome to Zhu Wang to show the add follow test.
Yes, so about the test, about do the ADF test about our dataset. So we should first read our dataset as a file path, and then we need to split the dataset into training and testing sets. And in our code, we split the 70% of the dataset into the training sets and 30% of the datasets into testing sets. And then we get every columns to do the ADF test, and then the series is equal to train columns is to get the current data of the columns, and then we do the ADF test about this lines data, and then we use a dictionary to save all the data like the ADF test statistic and the p-value and the critical value, and at last we print out of result of the ADF test.
Okay, we can show it.
Yes.
Yes, the humidity.
Yeah, and later there will be a table for showing all the columns. Yes, and here we first use 80% of training sets, and the result, it shows the temperature and the humidity's p-value is larger than 0.005, so it's not stationary, and the light and the
carbon dioxide.
Yeah. Carbon dioxide's p-value is less than 0.05, so it's stationary. And if we just use 70% of the data set into training sets, it's the same result.
Yes. Okay, that's all. And if you have any question, you can look at our reflection. Yes, that's all. And we use 3 different ARIMA model properties. First is about 70% of training sets, and this method we use the stepwise. For each step we update the model, and 80% of training session, and we also use the stepwise forecasting. And another model is we use batch forecasting. For each 10 step, we update the model. And the MEA, you can see the first model is the more prices. The result is more prices than other MEA, and the time. And we have result that if we use more time about the model, the results of precision is more precise. Yes, that's all. Thank you.